This is Miss Popelka, and we're going to do a little review over inequalities. And for some of you guys, this might be a review, but we're going to be doing some souped up, harder Algebra 1 inequalities very soon. So it's important that you understand how to do the more basic ones. So we're going to do just a little bit of review. You do have a notes page, and the expectation is that you are filling out the notes page along with me as we are proceeding. So first of all, we're going to talk about inequality symbols, and they should be familiar to you guys. I know for sure that this one and this one are familiar to you. Of course, this one means less than, and this one means greater than. You've been dealing with these since you were in elementary school. You know that, of course, the alligator eats the bigger number. So if I say 3 is less than 5, 3 is obviously a smaller number than 5. And if I use the greater than symbol, I can say 5 is greater than 3. That one, I know you guys have used a ton. That one is no big deal. Now, the ones that I'm not positive that you remember are, or that you've even been exposed to before, are this guy right here and this guy right here. And the line underneath tells you this is less than or greater than, or I'm sorry, less than or equal to. And then this one tells you it's greater than or equal to. The little line underneath tells you that there's a possibility that it could be equal to as well. Now, I know some of you are like, how the heck could something be greater than or possibly equal to something? Allow me to explain. I'm going to use a real life example. You guys all know that I'm not here with you right now because I am getting married this weekend, and I love my sister dearly. We have very different personalities. She's a planner. Frankly, this weekend, I just want to get married real quick and enjoy time with my family and friends, but I know she's going to stress me out about some silly detail. I appreciate it because she's taking care of a lot of work, but there are some things that are just going to bother me, and I know for a fact that I love my sister, but she will get on my nerves during my wedding weekend at least 3 times. So that means she might get on my nerves 3 times exactly, or she could get on my nerves more than that. That's what at least means. It means bare minimum, she's going to get on my nerves 3 times, but it could still be more. So if x equals the number of times my sister will get on my nerves, the inequality I would write is x is either greater than or equal to 3. That means she might get on my nerves exactly 3 times, hence the equal sign, or it could be more than 3 times. So, of course, she could get on my nerves 4 times or 5 times, or for that matter, a million times. Any number that's greater than 3. When we talk about the numbers that will work in an inequality, it's called the solution set. Those are the numbers that will satisfy an inequality. So in the case I've just given you, x is greater than or equal to 3, numbers in the solution set include, there's an infinite number of them. She could get on my nerves even 3.1 times, really. Maybe she just gets on my nerves a little bit after the 3rd time. Any number on the planet that's bigger than 3 is going to be part of the solution set for that particular inequality. For the second example, man, I've never been to Portland before. I'm really excited about getting out. I'm probably going to eat some good restaurant food. However, I've been pretty unhealthy lately with work and all kinds of things going on. So I'm going to try really hard this weekend to eat no more than 4 unhealthy meals. So if x equals the number of unhealthy meals I'm going to eat, then that means x could be exactly equal to 4. So I'm going to stick the line underneath it. I could eat exactly 4 unhealthy meals because I'm going to try to do no more than. That means that 4 is the top number of bad meals I want to eat. Hopefully, though, I'm going to stick to trying to eat a little healthier, and x will be less than 4. So x could be exactly equal to 4, or it could be less than 4, at least if I stick to my goal. So numbers in the solution set for this particular situation include 3, because 3 is less than 4, or 2, 1, or even 0, even though I know that's not going to happen. I'm not going to eat 0 unhealthy meals. So, of course, I can't eat -1 bad meals. So in this case, the solution set would only be these guys right here. We're going to assume that we can't eat 3.5 meals. I'm going to call them all, a whole meal. So remember, the solution set means any numbers that will work for that inequality. Now I've given you 2 examples, and I want you to try to write an inequality yourself. And in just a moment, I want you to restart the video. So again, pause the video. Oh, I just realized I forgot to write. Here I wrote x equals the grade he wants to earn. Here I forgot to write x equals the mornings I'll sleep in. But I want you to pause the video, try to write an equality yourself, and then restart the video when you're ready to check your answers. Hopefully you followed directions and you paused the video and wrote them yourself and then tried. So Jay wants to get at least an A. Okay, so if x equals the grade that he wants to earn, at least an A, which is a 90 in JCPS. So that means he'll be happy if it's equal to 90. So I'm going to put 90 on the other side of the inequality. But, of course, anything greater than 90 would be good too. So x is greater than or equal to 90. That means anything in the solution set is bigger than 90. For example, 2, I will sleep in no more than 1 morning. So if x is the number of mornings I'll sleep in, I'm fine if I only sleep in 1 morning. So x could be equal to 1, but I'm hoping that it'll be less than 1. So x, the number of mornings I'm going to sleep in, could be less than 1 or could be equal to 1. So I'm going to say x is less than or equal to 1. Another thing that you're going to be asked to do is once you figure out what numbers will work for an inequality, you're going to be asked to graph those inequalities and on a number line. And I'm going to show you how that works. So right now we've got x is greater than 5. So remember, that means that anything in the solution set could be any number on the planet that's bigger than 5. I do not have a little equal to symbol underneath there. So that means that 5 exactly is not a possibility in this case. Instead, it's any number that's bigger than 5. I mean, it could be 5.000001 as long as it's bigger than 5. So we're going to graph it on a number line. So what you're going to do is make yourself a little number line. 5 is our landmark, so I'm going to put a 5 right here. And I'm going to put a 4, and I'm going to put a 6. For my class, all you need to do is make sure that you have what's called the landmark number, the one that we're using in the number line, one before and one after. Now, you might remember from 6th grade that you graphed integers on a number line by using a little coordinate wherever the number was. So, for example, if you wanted to graph the number 4, you would put 4 on a number line, and you would put a coordinate right there above the 4. Graphing inequalities is fairly similar, but there's a little bit of a twist here. Because if I take a coordinate and I shade it in, I'm saying that 5 is a possible answer for the solution set, and it's not, because it's any number that is greater than 5. But I still need to show that 5 is kind of like my landmark number. So I am going to put a little circle there, but I'm not going to color it in. Notice the difference. Before, I colored in my coordinate. Now, I'm not doing that. I'm going to leave that circle open. So it does show that 5 is my landmark number, but it shows that it's not actually included in the inequality. Now, I've got to have a way to show on my number line that x could be any number that's bigger than 5. And of course, we could sit and we could put little coordinates on this number line all day long, but that would be a really big waste of time. So what we do to show that all the solution set is any number bigger than 5, we just take our pencil and we color in, we darken the number line to the right of our open circle, because any number to the right, of course, that's bigger than 5, is a possible answer for our inequality. So, open circle, because 5 is a landmark, but it's not actually included in our solution set. And then we're going to darken in every number on the number line that is greater than 5. So we're going to shade in to the right. This little arrow right here tells anybody that looks at my number line that I know this number line goes on and on and on, but I'm not going to spend all day long trying to write all these numbers. So that's a cue that I really mean any number that is bigger than 5 that's just going to go on and on and on forever. So this one is something very similar. So I want you to pause the video for a second, try to graph it yourself on the number line, then restart the video when you're ready to check yourself. I am going to assume that you have checked yourself, so I am going to go ahead and graph it. I'm just going to put a 3 right here. I know there are a lot of other numbers, but I'm just going to leave it be. 3 is my landmark number, so it needs to go on my number line. I'm going to do one number bigger, one number smaller. I'm going to make an open circle because, again, there's no equal to line underneath there. So 3 is not a possible number. And, of course, because it's any number that is bigger than 3, I'm going to color my number line in this direction to the right. And the arrow tells anybody that looks at my number line that I really mean that my solution set is any number greater than 3. So my solution set is greater than 3. So that could mean a million, that could mean 3.2, a gazillion, million, I don't even know if that gazillion's a number, different options for what the answer could be. Now we've got x is less than 7. You can probably take a good guess about what you're probably going to do. It's a very similar situation. I'm going to put my landmark number, 7, right here on my number line. One greater and one smaller. I'm going to make an open circle because 7 is not actually a possible option because there's no equal to line underneath my inequality. And then instead of shading to the right, I'm now going to shade my number line to the left because in this case, the solution set is any number that is less than 7. Again, my arrow helps somebody that looks at my number line to know that the solution set is anything smaller than 7. Now, for a little bit of a change, but it's still a very similar process, you're going to notice that this time I do have a line underneath the less than symbol. So that means that -2 is a possible solution to my inequality. So I'm going to put on my number line a -2. Remember that because we're in the negatives now that I'm not going to put a 1 over here. I'm actually going to put a -3 because negatives get smaller the more to the left you go. And I'm going to put a -1. That's all I'm going to put on my number line because as long as you have one smaller and one bigger, that's good with me. You're still going to do the circle, but I wonder if you can guess what you're probably going to do. Because 2 is a possible solution, I'm going to fill in the circle this time. So instead of leaving it open like I did before, I'm going to fill it in. But I'm still going to shade my number line, and because P is less than -2, I'm going to shade it to the left. And that indicates to the casual observer that any number less than -2 is a possible part of our solution set. And again, I filled in my circle because that line underneath the less than symbol means that -2 is actually part of our solution set this time. That means -2 is a possible correct answer. I'll bet you can guess where this is going. This time, x is greater than or equal to 8. So I'm going to put 8 on my number line. I'm going to put one bigger, one smaller. There's that equal to symbol, so that means when I graph it, I'm going to fill it in all the way. And then because x is greater than 8, this time I'm going to shade in my number line to the right. I'm going to use my arrow to indicate that it's going on and on and on to represent any possible number that is either equal to 8 or greater than 8. That is part of my solution set. So part of the solution set could be 9, 10, 100, 8.0005. There's lots of possible answers. So I want you to pause the video, try this one on your own, and restart the video when you are ready to check yourself. Hopefully you went through and did what I said, and you paused the video and you tried this on your own. I made a number line with my landmark 12 right in the middle of it. One smaller, one bigger. I'm going to leave my circle open this time because there is no equal to line underneath that inequality symbol. And because x could be anything greater than 12, I'm going to shade it to the right. So that should be my answer. Got another one I'd like you to try. Pause the video again, just like I asked you to before. When we come back, check your answer. Again, I put my landmark 12 right there in the middle of my number line with one smaller number, one bigger number. I'm going to leave an open circle again, and I'm going to shade to the left because S is any number that is less than 12. You're going to see some other ones on your paper right now. I want you to try them, and then I want you to restart the video, and I want you to check yourself to see whether or not you've done them all correctly. I'm going to assume that you follow directions and that you've paused the video. I'm going to go ahead and get started. So I've got my number line. I've got 2 in the middle. This time I do have that equal to symbol. That means I'm going to shade in my coordinate, and because M is anything bigger than 2, I'm going to shade to the right. The next one you should have tried on your own is B is less than or equal to -6. I'm going to put a -6, -7, -5 on my number line. I'm going to shade in my coordinate because it does have that equal to line. And B is anything less than -6. So I'm going to shade my number line to the left. The next one you should have tried is x is greater than 10. Again, I'm going to put my landmark right there in the middle. These are positive numbers, so 11 goes on the right, 9 goes on the left. I'm going to leave my circle open because there is no equal to symbol underneath. X is greater than 10, so I'm going to shade all the numbers on the number line that are bigger than 10 and put my arrow in there too. Next, we've got P is greater than -15. Put a -15 here, -16, -14, open circle, shade everything to the right. G is equal to or greater than 25. Landmark number 25, one bigger, one smaller. Fill in my coordinate, and I'm going to shade in anything bigger than 25. X is less than 13. No equal to symbol. So that means that I am not going to shade in my coordinate. I'm going to leave it open. And because X is less than 13, I'm going to shade it to the left. B is less than or equal to -7. Put a -7 here, -6, -8. That equal to symbol is there, so I'm going to fill it in. And B is anything less than -7, so I'm going to shade it to the left. And I think you actually have more on your paper, but I'll say you're good as long as we do this last one here. So I am going to leave my circle open because 8 is not equal to A. A is anything greater than 8, so I'm going to shade to the right where all of my numbers are greater than.